Welcome to the second lecture of the MOOC on Virtual and Augmented Reality for Training and Maintenance. During the previous lecture, we introduced the concept of extended reality, which includes, as we learned, augmented and virtual reality. And we explored its growing significance in the industry. During this second lecture, we will focus on the concepts of training, its connection to learning and maintenance, while discussing how extended reality can be used and impact these industrial processes. At the end of this lecture, you will learn the concept of training, how it differs from learning and how it relates to reskilling and upskilling, what is maintenance and what are the most known maintenance strategies, and finally, how to exploit extended reality to support training and maintenance. Let's start defining training. According to the scientific literature, training involves planned and systematic activities designed to help people acquire knowledge, skills, and attitudes. What does it mean? Imagine you decide to learn to play a new sport. First, you should learn and understand the game's rules and strategies, so acquire knowledge. Next, you need to develop practical skills. Finally, maintaining a positive mindset and a strong motivation would be crucial to endure the demanding training process, so the attitude. Industrial training is not that different from learning a new sport. We mentioned the three words skills, knowledge, and attitudes. You are probably familiar with the meaning of knowledge, but maybe not with skills and attitudes. When we talk about a skill, we refer to the ability to perform an action, a task, or a job with specific results that should meet required standards in terms of performance, such as time, effort, or accuracy. Like being able to successfully replace a malfunctioning part of your vehicle in a reasonable amount of time, without any damage, of course. In general, skills can be divided into different types. For example, we can have cognitive skills, which involve mental processes, or motor skills, focused on physical actions, procedural skills, which involve learning a series of tasks, and many more. There are different theories describing the process behind the acquisition of skills, and historically, skill acquisition has been seen as a progression through several stages. Effective training occurs when learners are given well-structured opportunities to learn the skills, knowledge, and attitudes through various methods, such as demonstration, practice sessions, and timely feedback. It's important to understand that while training and learning are closely related, they are not the same thing. Training is the process, while learning is the desired outcome. Learning means gaining new knowledge and behaviors through practice, study, or experience, leading to lasting changes in how we think, act, and feel. In the industrial context, the development and application of skills are crucial for achieving efficiency and productivity. This is why terms such as skilling, upskilling, and reskilling are widely used in the Industry 5.0 era. Upskilling refers to the process of enhancing a worker's skill to keep up with changes in technology, industry demands, or job requirements. On the other hand, reskilling is the process of developing a worker's skill in a different field of expertise, often to adapt to new job roles or market demands. The other important industrial process that we are going to consider in this lecture is the maintenance. When we buy a product as a consumer, we often pay attention to the warranty. Think, for example, of your personal smartphone. If it stops working, the maintenance support is fundamental. This service should be responsive, timely, and not that expensive. Sometimes we might even prefer one company over another for the maintenance support that it can guarantee. In industry, maintenance is the process of preserving equipment and infrastructures to ensure proper functioning and longevity. It requires regular inspections, servicing, repairs, and component replacement to prevent failures. There are several approaches to maintenance. First, we have preventive maintenance, usually where activities such as inspections, cleaning, lubrication, and part replacement are scheduled in advance to prevent failures. We then have corrective maintenance, where components are replaced or repaired after a failure has occurred to restore normal operation. Then we can have predictive maintenance, which exploits machine learning and data analytics to predict and prevent failures, optimizing resource use by maintaining equipment just before a failure. Industrial training and maintenance are in a phase of digital transformation. Talking about maintenance, industrial machines have been transformed from pure mechanical systems to cyber-physical systems that produce digital data. This huge amount of data is sometimes complex to understand and elaborate for a human being. Starting from Industry 4.0, companies have tried to explore the potential of augmented reality to transform this digital information into meaningful data. How many examples of workers wearing augmented reality headsets did you encounter in companies' websites in the last 10 years mentioning the Industry 4.0 revolution? So imagine that an operator can see data produced in real time and elaborated by algorithms to support decision making. If a condition for maintenance occurs, he or she can use extended reality to speed up the entire process, or even activate a remote support and still take advantages of the digital information overlaid onto real machines. Obviously, the operator needs to be trained before he or she is able to perform the task, and extended reality can be directly used during the training to safely simulate a lot of different situations. Don't forget that one of the great potential of extended reality is the ability to collect a lot of data that's hard to get in traditional learning settings. This data can focus on both the worker and how he or she interacts with the surrounding environment. For example, in extended reality training simulations for manufacturing assembly tasks, sensors in the headsets can track eye movements, hand gestures, and we can also track posture in real time. This tracking provides insights into the worker's engagement, attention, and skill in performing various steps. So now that we learned how digital transformation of the two industrial processes, maintenance and training, can benefit from extended reality technologies, we need to understand how they work. I mean the technologies, how they work, and how they can be effectively exploited.